In this presentation, I'm gonna talk about the paper, namely so motion estimation using block-based fast local area scaling, which is published on IEEE Transactions on Circuits and System for Video Technology. First, this method in this paper is block-based motion estimation, and they introduce the zoom motion vector. So the motivation for the block-based motion estimation is that mesh-based and object-based motion estimation algorithms give good motion vector accuracy. However, these two methods require high computation and are not compatible with the current video coding standard. So the block-based motion estimation, which require less computation and is compatible with the current standard, is more interesting in the field of video coding. There are many types of motion such as rotation, translation, zoom, and the zoom motion usually occurs in video for two main reasons. First one is object can move toward or away from a camera, and second one is the camera can zoom in or out on objects. So this is why this paper aims to tackle the zoom motion in video using block-based motion estimation. About the motion estimation method, there are two main parts: the zoom motion estimation algorithm and the fast version of this CME, which is the 3D zoom predictive diamond search. But the first one, CME algorithm searches the best zoom vector and the best motion vector. The zoom vector increases or decreases the candidate block size to achieve the zoom image, and the zoom candidate block is then scaled or resized to the same size as the current block by interpolation for block matching. In scaling or resizing the block, they use the bilinear interpolation with some adjustment. And of course, they introduce the zoom vector, the zoom scale and zoom range, which are parameter have to be chosen. The optimal zoom scale and zoom range are obtained by the statistical analysis. I mean, experiment on dataset to find the optimal zoom scale and zoom range. Okay, the figure one show the concept of CME. If the concept is quite close to the EBMA, or in this paper they call it conventional ME. Yeah, in the conventional ME, they compare a block in current frame with every block in the reference frame. But in the CME, they not only compare block to block like this, but compare with all different zoom version in the zoom range like this. So the measure of similarity, which is the SAD, is quite changed. They introduce the C parameter, which is the zoom vector. So from this formula, of course, we will know that the computation will increase the x and y in the search range and the c in the zoom range. Okay, to generate a scale candidate block, scaling transformation is used as the equation 2, where the dij is the displacement from the top left block index for pixel coordinate ij. Thus, the pixel position ij in the scale block is m plus d n m plus di and n plus dj, and the scale coefficient is calculated as equation 3, which is S equal to sum block size minus 1 over block size minus 1. And from the figure G, the integer position A, B, C, D are determined using the equation 4, and the intensity value of the scale pixel is calculated by interpolating this 4 value. The interpolation is defined as the equation 5. Okay, for the zoom scale and zoom range to be chosen, they perform experimental analysis on the 6 video sequence, and each point in this rate distortion curve is rate distortion scatter plot is an average of 6 video sequence, and we can see that the optimal performance is at the zoom scale equal to 64 and zoom range equal to 2. Of course, the CME with no fast algorithm will be require more complexity than the conventional ME, so they also propose fast scheme, namely 3D CPDS, containing containing two main steps. The first step is to predict initial zoom point, and from the experiment, more than 90% of the optimal zoom vector is placed on the pixel position of motion vector plus minus 2. So in this step, they use the conventional motion vector and 3 spatially adjacent block, left top and top right block, and a temporally correlated block are highly correlated with the current block. So from this information, they form 3 predictors. The first one is the average of the 3 adjacent blocks. The second one is the correlated block from the previous frame, and the third one is the zero vector. These 3 used to predict the initial zoom point. A point that yields the minimum matching error among these 3 predictors is selected to be the optimal predicted point and further used in the second step. Okay, that point, we know that that point is close to global minimum error point. So a small unit size search pattern is useful for finding the optimal correlated block. In this paper, they use 3D diamond search pattern for local search, containing 3 main steps. All search points within the search pattern are explored, and the matching errors are calculated. Second, a search point with the minimum error is assigned as a new search center, and this procedure will be repeated until the search center yield minimum error. So let's take a look at the computational complexity. Given the image size m by m, block size n by n, search range in minus r and r, in range of minus r and r, search step size in 1 pixel, zoom range CR, local search range using the diamond search pattern is R dash, and search step in local refined search is NSS. The operation count for CME, the number of search point equal to 2R plus 1 square to C plus 1, which is greater than number of search point in the EBMA by a factor of 2c plus 1, right? And each candidate position, sorry, each candidate position n square. Each block going through all candidate is this, and when searching the entire frame, operation counts this, which is greater than that of EBMA by a factor of 2c plus 1. And in the CMA with fast algorithm, it is equal to this formula. The first term is that of EBMA, right? And the second term, sorry, is this is that of EBMA because in the prediction of initial search point we use that method. And the second term comes from the local search. Let's take a look at the R and NSS. I mentioned that the local search use small unit size pattern search, right? So R dash will be small, and as we perform prediction of initial zoom point, so the initial point is close to global minimum error point. So NS, which is the number step to the global minimum, is also small. So the second term is small, right? So for the case of CME with fast algorithm, the operation count is a little bit greater than that of EBMA. Let's take a look at the number of search point and number of search steps. There are 5 search algorithms. The first 3 is from classical, and the last 2 is from this paper. We set the search range equal 7, the zoom range equal 2, and the local search range equal 1. Compare the CME with the EBMA. We can see that the number of search point is increased a lot, 5 times, and the number of search steps still one step. Let's take a look at CME with fast algorithm. The number of search point increased a little bit in the minimum case, and in the maximum case, I don't know, because the NSS is, I leave it as variable because in the paper they didn't perform experiment on this on a data set. And about the search step, it increased a little bit in minimum case, and this is increased. Okay, let's summarize. The advantages are accurate motion vector for video with zoom motion is proposed, and the first algorithm for practical application is also proposed using the 3D diamond pattern search. And the last one, this method is compatible with current video standards. The disadvantage is the increased number of search points. And in some cases, when dealing with very large or small objects or abrupt zoom motion, finding optimal zoom vector can be failed. And the last one is inaccurate motion vector when dealing with other kind of motions such as translation and rotation. Okay, about the critique, I think This paper proposed a simple concept of zoom vector based on the conventional ME with few computational complexity increase, but the method can capture zoom motion in videos. I think this is a worth trade-off between the accuracy and complexity. However, the statistic of the number of search points and search steps is not provided in this paper, so it's difficult to compare with the classical method. And the last one is the reasons why diamond search pattern is useful in this case is weak. Uh, it is reasonable to use a small unit size search pattern, but they didn't give the reason why the diamond search pattern. Okay, thank you.